Okay, so let's look at the next on our bullets, implicit differentiation. In fact, this one takes a different strategy entirely. Remember I told you in our previous classes that when you have y equals to 5x, this is an example of what? Explicit differentiation. Explicit in the word that it means what? External. Implicit means what? Internal. It is explicit because y becomes the subject of the formula. So if I tell you that y is equals to 2x squared plus 6x, does this become implicit or explicit? Because y is outside, right? Now, what of when I tell you that x squared plus y is equals to 5x? Can I call this an explicit differentiation? Why? Because the y is now what? Inside the equation, okay? Now, how do we tackle questions like this? It becomes a load of problems. And textbooks have not done enough to explain or expose the secrets behind this. It might amaze you to know that these things are just quite what I call the fingertips play. Now, let's take, for example, a question like this. I saw this particular question in a post-UTME exam, University of Benin to be precise. They said, y squared plus x squared plus 5x plus 6y equals to 7. Find dy upon dx. So as an example. And I'm very sure that students were just looking at this thing, calling it a puzzle. Now, when you have questions like this, they fall under the category of what? Implicit differentiation. Implicit in the sense that y is what? Inside the what equation. So look at what I tell students to do. Antidote. You are going to differentiate everything you see here. But note, whenever you are differentiating with respect to y, always attach dy over dx. I am going to recapitulate on that. Whenever you are differentiating with respect to what? Y. Always attach what? Dy over dx. That is the only condition. You don't apply it to x. Now let's go from the normal thing you know on the calculus. If you differentiate y squared, what are you going to get? 2y. Beautiful, because 2 times this one will give us what? 2, right? And when you take 1 from 2, it becomes 1, which is irrelevant. Now, because I differentiated with respect to y, what do you think I'm going to attach to this? Beautiful. Dy over what? dx. Close your bracket. There is an addition sign here. If you differentiate x squared, what do you get? 2x. Am I going to attach a dy over dx? No. Beautiful. Plus, if you differentiate 5x, what do you get? 5. Because whenever you differentiate a constant and a variable, the answer becomes a what? Constant. So what am I going to write here? 5 plus, what do you think I'm going to get here? 6, because you are differentiating a constant and a what? Variable. But mind you, because you are differentiating with respect to y, what do you think you're going to apply? Dy over what? dx. So this becomes what? 6. Then I'll write what? Dy over dx equals to, this is a constant, true or false? Whenever you differentiate a constant, what do you get? 0. The next thing now is to collect like terms. I have the y over dx, I have the y over dx. You bring them together, okay? So what do you have here? 2y dy upon dx plus, what do you have here? 6 dy upon dx. Every other thing in the equation will be taken over to the other side, okay? Now, if I take 2x to the other side, it becomes what? Minus 2x. If I take plus 5 to the other side, it becomes what? Minus 5. Mind you, what did the question ask me to look for? Dy over dx. So I can easily factorize this, right? So let's bring dy over dx out. If I do that, what will be remaining? 2y and what? 6. So tell them 2y plus 6, then add what? Dy over dx. What will it be equals to? Minus 2x minus what? 5. Now, finally, to get my final answer, I need to make the y over dx subject of my what? Formula. And if that is true, the y over dx will now be equals to, I am going to divide both sides of the equation by the coefficient of the y over dx. And what is the coefficient here? 2y plus 6. So if I say 2y plus 6 divided by 2y plus 6, what do I get? 1. And in math, whatever I do to the left, also do to the what? Right. So let's assume we've done this. So what am I going to write? Dy over dx equals to, what do I have here before? Minus 2x minus 5 divided by what? 2y plus 6. So I'm going to write my 2y plus 6. This gives us our final answer. You can even decide to tell them as a scholar that dy over dx is equals to, what is the sign common to these two? Can it be brought out? So it becomes minus, open the bracket. What will be left here? 2x. If minus and minus come in contact with each other, what do they become? Plus. Plus what? 5. Everything divided by what? 2y plus 6. And if some students want to quote me wrong, you just simply tell them that minus times plus gives us what? Minus. And minus times plus also gives us what? Minus. So from here we can also arrive here. So don't forget to add the keyword, or let's call it the jackpot word. QED, meaning what? Quite easily done. So you can jot.